Viscosity is the resistance of a fluid to a change in shape or movement. Viscosity denotes opposition to flow. We never have to confuse viscosity and density. For example, oil has more viscosity than water, but when we put both together, oil goes up. This tells us that water is denser than oil, so be careful with that. Viscosity may be thought as an internal friction between the molecules. Such friction opposes the development of velocity differences within a fluid. Surface tension is a property of a liquid surface displayed by its acting as if it were a stretched elastic membrane. Because of this property, certain insects can stand on the surface of water. A razor blade also can be supported by the surface tension of water. A lot of things actually. These objects are not floating, they are pushed through the surface, they sink through the water. Capillarity is the rise or depression of a liquid in a small passage, such a tube or a small cross-sectional area, like the spaces between the fibers of a towel or the openings in a porous material. Capillarity is not limited to the vertical direction. Water is drawn into the fibers of a towel, no matter how the towel is oriented. This may look fancy, but capillarity is present in nature. It transports water through the trees to bring nutrients to all the system of roots, branches, and leaves. Oh wow, it seems that we were truly transported thanks to quantum physics to the experiments. It is time to prove all these concepts.
Here we have two different liquids, one is soap and the other one is water. They are put on the same cup which has a hole down the cup. And we're gonna see which one is the first that empties the cup. Let's see. Now let's go with the experiment. We can see we take out our finger and the liquids are start to fall. You can see water is about to get empty in the cup. The cup of water gets empty 13.200 seconds after being released the liquid. And if we can see, the soap is just barely beginning. After almost 4 minutes later, the cup of the soap got empty. We can see there is a great difference of time between water and soap. This is because they have different viscosities.
In this experiment, we're gonna put some clips on the surface of the water. The clips will float thanks to the surface tension of that water has. Once we have all the clips on the water, well, let's put it together. Once we have all the clips in the water, we're gonna add a little bit of soap. The soap will make that the clips will fall almost immediately, as you can see in the video. Well, as we can see in this part, the clips are floating in the water. Now I'm gonna explain why they float. Every molecule is surrounded of another molecules in all directions, so the attractive forces between them get compensated. But in the molecules in the surface, they don't have more molecules, so they attract with a greater force, making a thin barrier in the surface that allows clip float. But when we add soap, the soap decreases the surface tension in water, so the clips will fall immediately. So now we know why we use soap to wash our clothes, because soap helps water to penetrate better into clothes, besides of dissolving the fats.
For this experiment, we will use paint, containers, water, and napkins. We will fold the napkins in this way so that they act as tubes and transport the water. Then we will fill the containers with water and the paint will serve to differentiate the fluids.
Liquids that rise in small bore tubes inserted into the liquid are said to be wet the tube, whereas liquids that are depressed within the tubes below the surface of the surrounding liquid do not wet the tube. Water is a liquid that wets the fibers of a towel. If we were using mercury, this wouldn't happen. When wetting does not occur, capillarity does not occur. Capillarity is the result of surface forces. The rise of water in a thin tube inserted in water is caused by forces of attraction between the molecules of water, the fibers of the towel, and among the molecules of water themselves. These attractive forces just balance the force of gravity of the column of the water that has risen to a characteristic height. The narrower the bore of the capillarity tube, the higher the wire rises. Mercury, conversely, is depressed to a greater degree the narrower the bore. And after a bunch of hours, these were the results. Doing all these experiments, we realized that we're in touch with all these properties every day. We learned that viscosity depends on the speed of the fluid, that surface tension can be broken with soap and detergent, and that capillarity occurs only when the thing that will transport the liquid is wet. Also, we saw that thanks to capillarity, plants can rise water without any external force. We hope to do more interesting experiments because it was pretty fun. We want to say thank you and see you later.